Okay, and welcome back to another exciting adventure on Real Business Cycles. Well, simultaneously on NyQuil. Or am I? Wait. Whatever. Let's talk about production. So in the last lecture video, we talked about labor markets and how labor markets operated. I explained how the firm got labor demand. I explained how the household derived labor supply. I explained the equilibrium of those two markets in the dynamic general equilibrium framework. And then I also drew it in a static framework, right, where we had labor demand being downward sloping, labor supply being upward sloping, and what would cause shifts to labor demand and labor supply. Right, so once labor demand is sort of figured out by the firm, right? Well, they're optimizing, so we need to then figure out how labor demand and the equilibrium in labor markets, where labor demand and labor supply, right, intersect. Once we have that equilibrium in labor markets, then we need to figure out, like, okay, what is that going to mean as far as production? All right, well, if you remember, production was this. Right, we had our source of technology shocks, A. We had capital, K, and labor, L. Right, so A is exogenous. The firm can't set A. Right, A just kind of happens by chance, so to speak. So the firm can't set A. All they can do is set K and L. So when they optimize, they figure out exactly how much they want to set K and L, like what they want to set them to. Now, that means that this is kind of like a three-dimensional function, and it sort of looks like a bowl almost. And so if we wanted to look at it in like a 3D sense, well, I mean, that would suck. That would really piss me off. So we're not going to look at it in a 3D sense because, well, if you've got like any sort of a 3D case, right, you're looking at something in like 3 dimensions. Right, so let's say we've got this, right? So I've got Y, the output, being a function of an input capital and an input labor. Right, well, there would be some curve, right? Let's say it's like, I don't know, here, where there's like this optimal production of, or this optimal combination of capital and labor, right? It could also be here, it could be here, it could be here. But either way, along this one particular curve, right, output is at a certain level. Now, if we wanted to go a little higher than that, right, well, what would that look like? Well, it would look kind of messed up. Let's just sort of assume it would look, I don't know, like this. Let's see, I can kind of draw like little, my drawing was quite bad, in case you haven't noticed. All right, so it's kind of starting to go out. Oh, it looks really terrible, actually. But this is higher. This is a higher level of production. And, well, if you're here, 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 or here, right, again, you're producing this level, this curve, this level curve of output. As I do away with that, let's sort of draw out what this thing would look like in 3D. It would kind of give me like a massive like dome thing, and then it would sort of, let's just say, I don't know, it goes out like this or something. And we would have all these different level curves of production. Now, this isn't really very fun to draw, is it? The answer to that is no. It doesn't even look very good. It looks like shit. Right, but those different levels would indicate different levels of production. And that's what it looks like in 3D space. Well, we don't really want to do that. right? I'm concerned about output and labor, and I'm not so concerned about capital right now. So what I could do is I could take this really effed up looking graph, right? So let's say I got kind of going like this, right? But if I rotated the graph to something like this, you're staring down at my middle finger. I promise I'm not a child. You're staring down my middle finger, and basically you're staring down the k-axis, the axis of capital. So what we're doing by doing that is we're holding capital constant, and we're only looking at changes in labor, how output responds to a change in labor holding capital constant. So we're going to be looking at labor and output holding capital constant. Right, well, what's that going to look like? Well, it's going to be a nice 2D graph. It's going to be something that we could actually kind of look at and understand here. What does that look like? Well, I'll just draw it over here. We're going to have output as a function of my labor input. Now, if you recall, this alpha is contained in the 0, 1 interval. What does that mean? Well, it means alpha is greater than 0 but less than 1. Now, what's that going to mean for the shape of this graph? What it means is that in both capital and labor, output's going to be increasing, but at a decreasing rate, diminishing marginal returns. Diminishing marginal productivity of capital and diminishing marginal productivity of labor. So it implies that the derivative of output with respect to labor, the first derivative, is positive. And that the second derivative is negative. So if its first derivative is positive everywhere, it means that it is upward sloping everywhere. It is always increasing. But if its second derivative is negative, what that implies is that while it is increasing everywhere, it is also increasing at a decreasing rate everywhere. Like this. Right? Now, because I'm holding capital constant, what that implies is in the notation here, I'm getting KT with a bar over it. The bar means it's being held constant. So we're not concerned about changes in capital, we're concerned about changes in labor, and how a change to labor will be affecting output, production. Why? Right, so this is what the production function is going to look like. So we've discussed production, we've discussed what production looks like for the firm, right? Because the firm has constant returns to scale. We can tell it's constant returns to scale because if we add the exponents of the two inputs of the production function, it will sum to 1. Alpha plus 1 minus alpha sums up to 1. Right, so it's constant returns to scale. There are two inputs, meaning we've got diminishing marginal productivity. It's increasing at a decreasing rate. Right? If you think about it like a roller coaster, right? Whee, roller coasters are fun. You're going over that hill, right? When you're getting ready to go over that hill, right? Yes, you are increasing in height. You're getting higher and higher and higher along that hill. But as you're getting higher along that hill, you slow down. That's what's happening here. It's just basically the hill never peaks here, right? Because while the roller coaster eventually reaches a peak and then starts decreasing again, but it decreases at an increasing rate because the more you drop, the faster and faster you go. Here, on the other hand, we get something a little different, right? It just kind of keeps going up and up and up and up and up. So this is what production looks like. Now, let's combine the production function and labor markets. Well, how do we do that, Jeremy? Well, you're about to find out. What we do is, well, we draw out both the production function and labor markets. So what's that going to look like for us? Well, what it's going to look like is the following. We're first going to draw labor markets. And draw a graph of the labor markets. Like this. Actually, what I'm going to do is I'm going to flip this around. That sounds like a better way to go about this for reasons that we'll be finding out about in, well, maybe 5 or 10 minutes. So we want to draw what's going on in the labor market. Like this. Now we're going to want to draw labor demand and labor supply. Labor demand, like this. Remember, it's a function L. Wages, capital, technology. We're going to want to draw labor supply. Like that, right? So we've got our labor markets drawn out. Hooray, good for us. We all deserve a cookie. Remember, we have our equilibrium and the labor markets at WT star and LT star. Now, I'm not labeling LT star just yet, and you will see why very shortly. I'm not doing that. Actually, what I am going to do, though, is I'm going to compress this just a little bit. I wouldn't worry about doing this on your paper because, well, you're not going to have too much to worry about with that, whereas I do. You got a lot more paper than I have board space. Like that. Now I'm not drawing or writing out this LT star just yet because there's going to be something that goes underneath this. You're going to want to draw the production function underneath the labor markets. So how do we do the production function? Well, remember we had Y, output, as a function of labor, right? Well, the vertical axes are different, right? The horizontal axes are the same, so we can literally just put one right on top of the other. And in doing so, right, well, what was the next thing that we wanted to do here? Well, we wanted to draw the production function. I'm going to be using orange this time. So we draw out the production function. Like this. Now, if you want to put a bar over K, you can. If you don't, well, you don't have to. All right, because, well, I can tell just by looking at this graph of Y and L that we're obviously holding K constant, right? K is being held fixed here. So, well, these are all, that's L, that's L. So what I can do is I can just draw a dotted line all the way down from here have our point where labor markets are in equilibrium. All right, all the way down where it touches this production function is the amount that gets produced using this amount, L star, of labor. So if this amount of labor goes into the production function, that means what comes out is YT star. So by combining the production function with labor markets, I have seen exactly how much production is, well, produced, how much stuff is made with some amount L star of labor at a wage rate W star. So when labor markets clear, right, where labor demand equals labor supply, they clear at a wage rate or a price of labor W star, and that's the real wage rate, mind you. And they clear at a real wage rate W star with an amount of labor input L star. Cool. But who gives a shit? Why do we care about this? Well, we care about this because what we want is labor. Well, we want labor markets, we want production, but what we really want out of this is an aggregate supply. We want an aggregate supply curve out of this. So how are we going to get aggregate supply from just looking at production and labor markets? Well, I'm going to draw a graph of YT and YT, output and output. right next to this production function. So output, Y, is on both the vertical and horizontal axes. And what this does is this actually serves as a way to translate, right, basically to reflect, to flip this vertical axis of Y over to the horizontal axis. And you'll see why we want to do that in a minute. All right, but how are we going to translate that? Well, we're going to translate it by drawing a diagonal line yt equals yt. We're going to have that right there. And you can draw that dotted line at yt star all the way over to this graph here of yt equals yt. Like that. Draw a dotted line down if you want to. You don't have to. What you do have to do is draw a graph over this. What we're going to do is we are going to draw a graph over this graph right here. So it's going to go right here. And I'm putting the price level PT on the vertical axis, and I'm putting output Y on the horizontal axis. All right, now what graph can you think of that has price and quantity in it? All right, when you think of price on the vertical, quantity on the horizontal, what kind of a graph do you think we're going to be looking at, right? What two functions, what two equations are we going to be curious about looking at? Well, let's see. Output is a function of price. It sounds like supply, doesn't it? Yeah. Demand's a function of output and price. Oh shit, what do you know? Huh. That's the supply and demand space. And step 7. we draw that dotted line, right, from where yt equals yt up into pt yt space. All right, so I'm just going to do it like there for now. Now, what we get from that is aggregate supply, but we have to think about what some of the implications of the model were, all right, what some of the assumptions of the model were going in. All right, well, we assumed that prices were fully flexible, or 100% flexible, meaning any sort of shock that we get, prices immediately respond. Okay. Let's think some more. Think about this a little bit more for a minute. Prices are 100% flexible, so they immediately respond to a shock of some sort. Now, the model also satisfied both welfare theorems of economics, and the model also, what else did it do? Oh yeah, it had perfect competition in all markets. So we have perfect competition in all the markets. We've got perfectly flexible prices. Well, really by the satisfaction of the two welfare theorems, we ensure perfect competition as well as Pareto optimality. That must mean then, right, using our Sherlock Holmesian deductive reasoning, that aggregate supply would be perfectly vertical. We'll label it AS. So step 8 is draw a vertical aggregate supply curve. So this covers the supply side of the economy under the real business cycle model. Because we have labor markets, right? Households and firms both optimize. We figure out exactly how much labor the household wants to provide and how much labor the firm wants to demand. That gives us labor supply and labor demand. And we get a unique intersection point, right? A unique equilibrium in the labor market where L star labor is provided at a wage rate, a price of labor, W star, a real wage rate, mind you. And that means if L star gets supplied in the labor markets, then L star goes into the production, and the production function down here, L star, yielding this level of production. We then, if this is our level of production, right, what we really want is to have output on the horizontal axis rather than the vertical axis. So we just translate it, right? And so just rotate it 90 degrees, put it on the horizontal axis, and we just draw a dotted line up until we get to price and output space, where we draw a vertical aggregate supply curve. And the most important reason why that aggregate supply curve is vertical here is because that prices are fully flexible, meaning aggregate supply is independent of prices in this model. So I'm going to write that down here. So aggregate supply, AS, is independent of prices in the RBC, real business cycle, model. So this captures the supply side of the economy. Now it's time to draw out the demand side of the economy, which will come in the next lecture video. So until then, enjoy your NyQuil trip, and when we all come down from the NyQuil trip, there will be another video talking about the demand side of the economy and the real business cycle model. So catch you next time on Real Business Cycles with Jeremy on NyQuil. Whee!